What's up, Pussy Star Nation? My name is Flynn Scott Wilson. This is the Flynn Scott Wilson podcast. It's the 12th of November 2021, and your name is Flynn Wilson / family of Flynn Wilson / I blew the fuck up. I'm fucking famous now. Probably a businessman that nailed the fuck out of marketing and keeping it $1.50. As you can see here, I keep it $1.50. I try to, So yeah, that's the only way I blow the fuck up. Not too worried about that though. But let's go. Let's get into it. Alright. Oh yeah, what the fuck am I doing? Doing some chemistry work. Let's go. Focusing on my weaknesses. I did 2 exams per exam. 2 exams per exam. 2 exams per exam. Figured out what I was shit at. Now we're fucking focusing on it. Let's go into the new coach. Sign in. What the fuck is my sign in? I can't remember. I'll just instantly sign in for me. Let's go. Chemistry. Organic chemistry. Pause, buddy, pause. Organic. Is this organic? Yep. Okay, let's see my weaknesses. Bipeptides and amide linkages. What the fuck? We'll just start with polymerization. All of these I'm not that good at. Polymerization, oxidation reduction. Decent at. Lab techniques, what the fuck is it about? Reaction schemes, what the fuck? I'll just go on polymerization. I don't know, dipeptides and amide linkages.
Welcome to this video on
This is level 2.
naming organic compounds. The first thing you
right?
need. Welcome to this video on naming organic compounds. The first thing you need to know is that level 2 material is incredibly important for level 3 organic chemistry.
Oh, yeah.
And right throughout the organic chemistry topic, we're going to be referring back to the level 2 content that you should have learnt last year. In this video, we're going to be covering naming organic compounds and isomers. So at the start of each point, I'll briefly touch on what you need to have known from last year.
Don't touch
So
me.
to start off with naming
I'm not
organic
funny.
compounds,
I'm not
at
funny.
level 2, we learned all the prefixes which get matched up with the number of carbons. So for example, 1 carbon has a prefix of meth. We have 5 carbons have a prefix of
can you
pent,
move the fuck
and
on?
so on.
Oh,
These
this
are
is
all
naming
listed in the
compounds,
table here.
fuck's sakes.
Now while this prefix dictated the number of carbons,
Why am I watching
welcome
this?
to this video on polymerization. Now, polymerization is when you take single molecules, and we call these monomers, and you join them all together to get one long chain, which is called a polymer. And polymerization is the process of how that happens. Now, we did learn some stuff about this in level 2, and this was all to do with addition reactions. So we'd have a group of alkenes with double bonds in them, and that's what we knew polymerization was. Now, those double bonds would break open, and one open bond from one molecule would connect to another open bond from another molecule. And all together, they'd be pulled up and make one long chain called a polymer. So the terms we needed to learn were a monomer, which are these individual parts, and polymer, which is the long chain once they've added all together. So if you want more detail on this, go to the level 2 organic chemistry video on addition reactions. There's more in there. Now, the one we're going to focus on today is condensation polymerization. And it's called this because they all undergo condensation reactions. Now, we saw a few condensation reactions in video 2 in reaction schemes. Now, 2 of the most notable were when a carboxylic acid and an alcohol create an ester. Now, that has a byproduct of water. And the same thing with an acyl chloride and alcohol create an ester, and they have a byproduct of HCl, hydrochloric acid. Condensation reaction is when 2 small particles, one from each of the reactants, joins together to make another molecule. In this first one, we get a hydrogen from alcohol and an OH group from the carboxylic acid, and that joins together to make H2O, or water. In the second one, we have a chlorine group plus an H from alcohol to join together and make HCl. Because they join together, it's called condensing, and therefore these are condensation reactions. Now, this is relevant because in this video, there's going to be condensation reactions where we remove small particles, and in turn, bigger particles or molecules join together to make polymers. Now, there's two different ways that you can make polymers with condensation polymerization. Now, the first one is when you have one type of monomer with two different functional groups. And you need two different functional groups, kind of like if you're linking arms with somebody to create a long person-to-person chain. You need to link arms on both sides, so you have two arms, or in the case of a monomer, two functional groups, both of which could link to the next molecule. So we could have one molecule with two different functional groups, or we could have two different molecules with each of their functional groups twice. So they'd join together, and then they'd have two other functional groups on the outside to create one long polymer.
Facts.
So let's look into detail about how some of these work, and we're going to cover 5 different reactions relating to polymerization today. So let's start by looking at two different molecules that have their functional group twice. Now, the first example is forming a polyester. Now, polyester is a really common fabric. A lot of things are made out of it. Now, this is designed by having a carboxylic acid, and it has two carboxylic acid groups on it, so we call it a dicarboxylic acid, and a diol. Now, this is an alcohol with two alcohol groups on it. And what you get is the OH from the carboxylic acid group and the H from the diol, from the alcohol part, join together to make H2O. They make water. And this leftover oxygen from the alcohol group will join straight up to the carbon from the carboxylic acid group. And this happens again as this water molecule is released, and again as this water molecule condenses together. And what you end up with is you have one long chain where these two original monomers alternate together. So they're all connected by that ester-like bond where that original oxygen holds the two molecules together. And you'll notice there's plus 3 H2Os on the end. And that's because you've condensed out the water. There's a condensation reaction. So this is a dicarboxylic acid, a two-ended carboxylic acid, plus a diol, a double-ended alcohol, and that goes to polyester, which means many esters. So you're getting lots of ester bonds again to make one long chain, plus that water which is condensed out. Now we could also do this with an acyl chloride which has two ends, called a diacyl chloride, and a diol, again, that alcohol that has two ends on it as well. You'd get the same kind of thing. You'd still get polyester, but instead of an OH and an H being condensed out to make water, you'd have an H and a Cl condensed out to make HCl. So this is how this works when you're creating polyester, which is a common fabric. Another example we can look at is polyamides. Now again, this creates useful plastic-like things like nylon. So here we've got two groups. Here we've got an amine group, and we've got a carboxylic acid group. So we could remove an H from the amine group and an OH from the carboxylic acid group. Yes, would be either H from this amine group here. And directly this carbon would connect up to the nitrogen here. And the same thing would happen when we have OH and H, OH and H, all condensed out to make water. And so that gives you a final result with an amide link in it. And you'll see the nitrogen on one skips right over this H.
I forgot to open Anki. What the fuck's going on there? Oh, okay. We chillin'. Organic chemistry. What is a polyester?
to this carbon here. And you can call this type of bond an amide link. Here we have a diamine, because we've got a two-sided amine, plus your dicarboxylic acid, your two-sided carboxylic acid, going to a polyamide. And that's a thing like nylon. So we could also do this, instead of having a double-sided carboxylic acid, we could
Pull up in a skirt.
could have a double-sided acyl chloride. And in the same way, instead of OH getting kicked off,
Pull up in a skirt. Pull up, then I go skirt. Resume timer. Let's go back to studying.
welcome to this video on polymerization, one of the reactions we learned about in the last video, called acid hydrolysis. Now, acid hydrolysis will acid, we could have a double-sided acyl. When we have OH and H, all condensed out to make water. And that gives you a final result with an amide link in it. You'll see the nitrogen on one skips right over this H and OH group, which has been condensed out so it makes water, and connects right up to this carbon here. And you can call this type of bond an amide link. Here we have a diamine, because we've got a two-sided amine, plus your dicarboxylic acid, your two-sided carboxylic acid, going to a polyamide. And that's a thing like nylon. So we could also do this, instead of having a double-sided carboxylic acid, we could have a double-sided acyl chloride. And in the same way, instead of OH getting kicked off, you'd have the Cl group getting kicked off. So you wouldn't have water condensed out, you'd have hydrochloric acid, HCl, being condensed out in this case. So this is how you form polyamides. Now, one thing to note, if you ever spill an acid on nylon, you'll notice there's a big hole in it pretty much straight away. And this is because one of the reactions we learned about in the last video, called acid hydrolysis. Now, acid hydrolysis will break up this amide link. So you can say that acid hydrolysis will break this bond. So it will put it back to those original monomers, which are the original molecules. And the example is, if you can spill acid on nylon, you're going to get a hole because it breaks up that long nylon strand or that long nylon polymer. So that's what you need to know with polyamides. Now, the third example we're going to look at is proteins. Now, proteins are all throughout your body. They make everything happen. Structures, they carry out important functions. So if you study biology, you will have heard this term polypeptide chain or amino acid chain throwing around. This is where you have what's called amino acids, which are a derivative of amides, and they're individual monomers that join together in a long chain. So here we've got one amino acid, and you'll notice that this has an NH group, so an amine group on the end, and it has a carboxylic acid group on the other side. And so what happens is you can kick off the OH of the carboxylic acid group, kick off one of these hydrogens here, and then this carbon will directly connect up to the next molecule's nitrogen. And you'll see this happening here. Here you've got the carbon with the double bonded O, which is this carbon here, and it connects directly up to the next molecule's nitrogen, back on here once one of those H's has been kicked off. And you notice if it's missing an OH and an H, water is going to be released as a condensation part of this reaction. Hence why it's called condensation polymerization. And this is an example of one monomer that has two different functional groups coming together to form a polymer. Now, as well as the word polypeptide, occasionally you'll see the word dipeptide come up. Now, this is just if there's two amino acids joined together rather than a long chain of amino acids. So, for example, here you've got an amine group, you've got a carboxylic acid group, and they join together, and there's only two of them. Again, H2O is released as a part of that condensation reaction. You're going to end up with a dipeptide. So you've only got one peptide bond in the middle holding it together. So now that we've done three different types of condensation polymerization, we're just going to have a little, and they join together.
It's the exact same fucking molecule that you've drawn. You just flipped it upside down.
And there's only two of them. Again, H2O is released as a part of that.
So what is a dipeptide? Two amino acids joined.
That condensation reaction, you're going to end up with a dipeptide. So you've only got one peptide bond in the middle holding it together. So now that we've done three different types of condensation polymerization, we're just going to have a little recap of what we've done. The first thing we learned about was polyester. And this can be formed when there's many ester bonds. So that could be a carboxylic acid with two ends, so a dicarboxylic acid and a diol, which is a two-ended alcohol, and that might make polyester. Or you could do an acyl chloride plus a diol. Again, an acyl chloride plus an alcohol goes to an ester. And if you do many of these things, both of which have two ends on them, you're going to get polyester, a long chain. Now, the difference is in what you'll condense out. So with the carboxylic acid, you're getting rid of an OH and an H, versus with an acyl chloride, you're getting rid of a Cl and an H. So you condense out HCl rather than water. We also learned about polyamides, where you can have an amine plus a carboxylic acid goes to a polyamide. You can also do an amine plus an acyl chloride goes to a polyamide as well. Finally, we learned about a type of polyamide that's commonly called polypeptide.
Hey, yo, what the fuck? Okay. What is a naturally occurring polyamide, also called polypeptides, made amino acid monomers.
And they're made up of amino acid monomers. And proteins are critical to the function and survival of all living organisms on the planet. Now, the last two things we're going to learn about are to do with salt making. The first of these is creating triglycerides, which are actually called fats and oils. So if you want to create fats and oils, these are triglycerides of all living organisms on the planet. Now, the last two things we're going to learn about are to do with soap making. The first of these is creating triglycerides, which are actually called fats and oils. So if you want to create fats and oils, these are triglycerides, and this is how it works. It's with a polymerization reaction. So you can get a carboxylic acid and an alcohol going to an ester in water, and we learned this in the previous video, and we've seen it come up again in this video. But this happens on a particularly big scale. So you can get what's called a 1,2,3 triol. So this is a 3-ended alcohol. There's an OH group, OH group, OH group, and you can mix it with fatty acids. Now, fatty acids means that you've got an amino acid with a very long chain of carbons following it on. Now, you get 3 of those, you're going to have 3 different reactions where this alcohol group and this fatty acid come together, this amino acid group. Now, they're going to join up in a condensation reaction, and you're going to get one molecule which has 3 long strands. And this is called a triglyceride. So the things that you need to know is that you need to have a 1,2,3 triol, which means you've got 3 alcohol groups right next to each other, and 3 long fatty acids. So this has carboxylic acid groups at the end of a long chain of carbons. And that's going to form triglyceride. And like always, you're going to condense out the water. This OH group and this H group come together.
Screenshot this. Just add a motherfucking image in there. Fuck it.
Now, one other thing to note is that these R groups, these chains of carbons, can be really different and really long to each other. They don't all have to be identical. And depending on what these R groups are, gives the properties of whether you create a fat or an oil. And these triglycerides lead on to our 5th and final type of reaction. This is saponification, which is soap making. Now, this is when you have the base hydrolysis of a triglyceride. And we just learned about triglycerides, which is where you get these 3 long fatty chains of carbons where the carbon
saponification of a triglyceride.
Carboxylic acid group connected back up to that alcohol, so we've really got 3 different esters here, and then you can put a base on it. Now, what happens, and we learned this in video 2, is when you put a base on things, it breaks open this bond again. And when you do base hydrolysis of an ester, you're going to get a carboxylic acid salt. Now, the interesting part is a carboxylic acid salt, in this case, if you do it with sodium hydroxide, gives you 3 different soap molecules. So you can put sodium hydroxide on triglyceride, which is fat or an oil. You're going to get glycerol, which is a 3-ended alcohol coming out of it, because we always get alcohol when we react things with esters. But these 3 carboxylic acid salts are the important part. They are called soap molecules. And if you remember the summary from esters, is this last part, which is where you undergo base hydrolysis, sometimes called saponification, to give a carboxylic acid salt. So this is one reaction with triglycerides, which actually breaks up the polymer chain to give you soap. So here's what you need to know. Carboxylic acid salts are the important part. They are called soap molecules. And if you remember the summary from esters, is this last
That shit barely makes sense, but you know what? We going with the flow, yo.
Last part, which is where you undergo base hydrolysis, sometimes called saponification, to give a carboxylic acid salt. So this is one reaction with triglycerides, which actually breaks up the polymer chain to give you soap. So here's what you need to know from this video. You need to know that there are 5 different reactions which you'll have to understand. And the first one is polyesters, which means we have lots of esters all connected together in a long chain. And this can be formed with carboxylic acids and alcohols. Now, again, we need 2 ends on each of those. It can also be done with a diacyl chloride and an alcohol as well. Now, when we do polyamides, this is things like nylon, we have carboxylic acids and diamines, so a 2-ended amine group. Now, this undergoes acid hydrolysis to actually create your polyamide. And finally, we learned about polypeptides, which are also called protein. So these are long chains of amino acids. And amino acids are single groups in your body, and on one end they typically have a carboxylic acid group, and on the other end they have an amine group. And those will join together one by one to make long chains of amino acids, which are called proteins, and they're really prevalent in our bodies. So that's the first lot of polymers that we found, and all of them condense out either hydrochloric acid or water. And finally, we learned about esters. Now in esters, we learned about creating a triglyceride. So this is a long chain carboxylic acid. So this is when you've got this carboxylic acid, which has a long chain of carbons off it, and they interact with a 1,2,3 triol. That means that you're going to get each of these alcohol groups joining up with one of these carboxylic acids. So this makes a triglyceride, which are really 3 esters all connected together. Now, the interesting thing you need to know is this is called fats and oils. In everyday life, fats and oils are triglycerides. Now, the final thing we learned was about soap making, or called saponification. And this is where you get one of these triglycerides, you mix it with sodium hydroxide, and this forms a carboxylic acid salt, otherwise known as soap. So if you want to get all chemistry about it, this is formed by base hydrolysis of an ester, which we touched on in video 2. So this is everything you need to know for condensation polymerization.
We didn't even go over, like, what's this one about? Oxidation reduction.
Welcome to this video on more of this acidified permanganate or acidified dichromate.
Is that the only complicated thing? Lab techniques. What does it mean, lab techniques? Oh, is this like distillation? Okay, good. I need to go over this.
Welcome to this video.
Ooh. $100 for all these PSP games. Let's see. Buzz Jr., Dino Dune. I have a 100% positive feedback. I've got 1 feedback. Let's go. Let's see, have you arrived yet? Two of the people that bought from me are just fucks, eh? Absolute fucks. Four views, 12 views. Oh, you guys aren't gonna sell. Ten views. Yo. 5 views. Yo. I'm on edit to watch this. Yo. Pull up in the skirt. I thought one of them had a bit. Oh, that was... Okay, my bad.
Video on laboratory techniques. Now, in organic chemistry, you learn so many different reactions, but when you do these reactions in a lab environment, you need a whole lot of apparatus and different reagents. And that's what we're going to learn about in this video, because you're going to have to write about them during your exams. So we're going to learn about 5 different types of apparatus. We're also going to learn what they're used for and learn an example so that you can pull those out in your exams. So the first one of these is the separating funnel.
What the fuck? Okay.
Now, this is used to separate compounds based on different levels of solubility.
Right, that makes sense.
viscosity. So this is when you have two liquids that don't mix with each other. So you have a top layer and a bottom layer that's more dense. And you'll notice that the more dense layer is sitting right on top of this tap here. So you can have a tap that you turn on and this dense bottom layer will slowly run out and you can collect in a conical flask. And it allows you to separate out the top layer with the bottom layer using this funnel. So this is called a separating funnel. And the most common use you might see for this is when you're separating an ester in an aqueous solution or the water that's around that, because esters are insoluble in water. So you can use one of these to separate them out. The second thing we're going to learn about is distillation. So distillation is where you get a round bottom flask and you're heating things up. And things have different boiling points. So what you'll get is you'll get a product that evaporates out of this round bottom flask, goes up through this column, and comes back around down through this condenser tube. Now a condenser tube exists because you get this hot gas that's water. So you can use one of these to separate them out. The second thing we're going to learn about is distillation. So distillation is where you get a round bottom flask and you're heating things up. And things have different boiling points. So what you'll get is you'll get a product that evaporates out of this round bottom flask, goes up through this column, and comes back around down through this condenser tube. Now a condenser tube exists because you get this hot gas that's been heated up and evaporated, and then you get the cold water that goes around and around outside this condenser tube. So it cools down the tube, and therefore the gas that's inside this hollow tube will get cooled down as well. And that means it condenses, it turns into a liquid, and then it runs off in liquid form to be collected. So this is distillation. And the common example that we learned in a previous video was to get aldehydes separated out from primary alcohols and from carboxylic acids. Now, fractional distillation is very similar, except you have this extra column on here called a fractionating column. Now, this is something that's filled with plates or beads or something with a high surface area. And that's because when something evaporates, it hits this high surface area, it'll condense and fall back down again. And it just means that it's going to get re-evaporated, so only things within a very specific temperature will make it right out the top of this fractionating column.
What?
So there's some pros and cons to this approach. The con is it takes much longer because things keep condensing, don't make it all the way to the top, down into this condensing column. But the plus side is that you're much more accurate in what you're doing. So fractional distillation has almost the exact same definition as distillation. It separates mixtures based on the boil. boiling point, but it's much more accurate and much slower than regular distillation. And again, the best example is removing aldehydes from those primary alcohols and those carboxylic acids, or in a mixture when it's getting oxidized.
Okay.
So the next thing we're going to look at is filtration. Now, filtration is when you want to remove solids from liquids or liquids from solids. So you get this filter paper or this filtration paper above a conical flask, and you put that inside a funnel, and you'll pour the whole substance, which might have a precipitate in it, so a solid suspended within the liquid. Now, the liquid will go through the filter paper, down the funnel, and into the conical flask, whereas the solid will remain there in this filter paper. So this is common when you want to remove a drying agent, and we're going to cover this just later on in this video. And the final thing we're going to cover is reflux. Now, reflux goes ahead when you want to speed up your reaction, but you don't want to lose your compounds to evaporation. So, for example, you might be heating a whole bunch of compounds to try and get a reaction to go on to evaporation. Reflux goes ahead here. And the final thing we're going to cover is reflux. Now, reflux goes ahead when you want to speed up your reaction, but you don't want to lose your compounds to evaporation. So, for example, you might be heating a whole bunch of compounds to try and get a reaction to go on. The problem is that you're evaporating, for example, an alcohol, and it's losing alcohol before you get the chance to do the reaction. So what you do is you have this reflux column. So the evaporated alcohol, for example, would go right up this tube, then you'd have water going around the outside of this tube where you have your evaporated compound. That would cool the tube right down, cool down the evaporated gas into a liquid, and it would fall back down into this flask again so it can continue reacting. So this is a way to heat things up without losing compounds to evaporation. So the most common example you'll see of this is acid and base hydrolysis of an ester. So this is when you break up an ester with an acid or base. So these are the 5 different apparatus that you need, or 4 if you count distillation, and fractional distillation is a similar kind of thing, what they're used for, and the examples that you might encounter. Now, before we finish, we're going to look at 2 more reagents we can use in a lab to help us carry out these experiments. So the first one of these is to remove or neutralize acid. You might have added acid in to make a reaction happen in the first place, but you don't want any left over at the end. So you'll add in sodium carbonate solution, which is Na2CO3, or sodium hydrogen carbonate solution, really similar, NaHCO3. And an example of this happening is when you want to turn a tertiary alcohol into a haloalkane. So what happens is you add in a lot of HCl, hydrochloric acid. What that does is it kicks off the OH group from the alcohol and replaces it with a Cl group from this hydrochloric acid. And that would leave you with Cl attached to an alkane. So going from a tertiary alcohol to an alkane. You might want to remove the excess HCl if you put too much in to start with. In that case, you'd put in sodium carbonate or sodium hydrogen carbonate to neutralize the acid. Now, the second thing we might want to do is remove the H2O, remove excess water that's hanging around after a reaction, particularly in a condensation reaction. So for this, we use calcium chloride, which is CaCl2, or sodium sulfate, which is Na2SO4. So for example, in this reaction we looked at with a tertiary alcohol going to a haloalkane, we noticed that the OH group of the alcohol got kicked off and a Cl group replaced it. But you'll notice that means we're left over with an H from the HCl and the OH left over, so that joins together to make water. But in that reaction, you don't want a whole lot of water left over, you just want the haloalkane. So you add in, for example, calcium chloride, or you could add in sodium sulfate, and both of those things are going to remove that excess water that was created in that condensation reaction. So those are 2 uses and 4 reagents that you might need to know in the lab to getting things done. Right. So this will come up in your exams. They'll give you a situation where they're actually trying to do a common reaction and say, hold on, in the laboratory, how would this actually work? So for example, we could look at esterification, which is making esters. So they might say the carboxylic acid plus an alcohol goes to an ester plus water. Now this is something which comes up a lot in organic chemistry. But if you actually wanted to carry that out in a lab, it's a little bit more complex. So they might give you a series of steps and ask you to comment on how they would work in a lab or what the purpose is. So number 1 might be mix the alcohol and carboxylic acid in a conical flask with H2SO4. You have to say, well, the H2SO4 is a catalyst. It helps speed up the reaction. Step number 2 might be they then heat it under reflux. And you'll say, oh, well, that keeps those volatile compounds reacting. Remember, reflux comes in when we want to heat things up to speed up the reaction, but we don't want things to escape based on evaporation. So for example, in this case, the alcohol might evaporate, but we want to keep it there reacting with the carboxylic acid so that we can make our ester. So we need to explain that the point of reflux is to keep it all together reacting in one conical flask. Then they might say in a separating funnel, we need to add aqueous sodium carbonate. Now, if you remember, sodium carbonate neutralizes the acid. It also releases CO2. And we have to do it in a separating funnel because esters don't mix with other aqueous solutions or with water. So we need to separate that out with a separating funnel. Then we want to add the anhydrous CaCl2 or calcium chloride, and that's because it'll remove any extra traces of water that's produced in that reaction. Then they might say you'll need to filter it, and that's to remove any extra bits of this calcium chloride. Finally, you might need to distill this and collect a fraction which has the boiling point of ester. So this removes the ester from any of these other compounds it's still mixed up with that have a different boiling point. So they might give you all of these kind of steps or just one or two of those steps, and you would need to comment on why that apparatus was used or why those reagents were used. Now it's more common for you to get a smaller step, for example, explain why this equipment here was used for the hydrolysis of a triglyceride, and you have to explain that this is used to speed up reactions when you don't want to lose those volatile compounds. So you just have to explain this in your exam, that this heat increases that rate of reaction and the condensation up the top helps stop volatile chemicals being lost to the environment. So here's what you need to know. You need to know the 5 different apparatuses and what they're used for. So a separating funnel is used to separate compounds based on solubility. So if things don't mix together, they're insoluble, the more dense layer will go on the bottom, and you can run that off with a separating funnel using the tab. The second thing was distillation. This is when you want to separate things based on their different boiling points. And this is the same as fractional distillation, although this is a slower process, but it does separate things more accurately than just straight distillation. The difference just is that you'll have a fractionating column. And the final thing we learned about was reflux. And this helps to speed up an organic reaction without losing those volatile compounds which might otherwise evaporate. We also learned about 2 uses you'll need for reagents. The first is to remove or neutralize acid. The second is to remove water. So if you're neutralizing acid, you might see sodium carbonate, or you might see remove compounds which might otherwise evaporate. We also learned about 2 uses you'll need for reagents. The first is to remove or neutralize acid.
In lab techniques, what is the use for reagent native? Calcium chloride, CaCl2, or sodium sulfide. What the fuck? Na2. Yes, sir. Used remove H2 Fuck it. Play.
The second is to remove water. So if you're neutralizing acid, you might see sodium carbonate, or you might see sodium hydrogen carbonate solution, so NaHCO3. Now, if you're removing water, you might see calcium chloride, CaCl2, or sodium sulfate, Na2SO4. So this is everything you need to know for the lab techniques in organic chemistry.
Cool.
Welcome to this video on laboratory techniques. Now, in organic chemistry, you learn...
Pause. Alright, now let's see if I can move forward the date. Fuck it. See if this works. Dope. Pull up, echo, skirt, skirt, skirt. That didn't seem to work.
Welcome to this video.
Oh man. Guys, setting my date and time forward didn't help. Okay. Pull up, echo, skirt, skirt, skirt. What the fuck happened? Oh, I quit out of study time. Why am I confusing myself so much? Okay. Let's set this timer, and then let's... I don't know. I don't know. This one? Pull up, I go skirt, skirt, skirt. Let's just have a look for garage sales. Not a proper look, but just love garage sales too much, man. See, we're even more garage sales. I just love them so much. No, she doesn't. No, sorry, Stevie, it's all kid stuff. No, sorry, no one has any video games. Ah. Message that person out? What the fuck, man? Refresh the fucking page. I don't know what the fuck's going on. It says I've got internet. Do I have internet or not? Tell me. Why the fuck aren't you loading? Currently offline. Currently online. What the actual fuck is going on right now? Do I have Wi-Fi or not? Okay, go to my messages. Okay, go one new message. Okay. Your connection was restored. What the fuck are you talking about? Okay. Messages. I can't open your messages. Okay. Did I message you or not? What the actual fuck? Boo-doo, boo-doo, boo. Dude, this podcast is still going, is it? Shit. Okay, well, anyway, see ya.